So we can use the formulas, the chemical formulas of compounds to calculate their percent composition. So in this lecture, we're going to learn how to calculate the percent by mass of each element in a compound. And we can do this just looking at the formula of a compound. As an example, let's take sodium chromate, Na2CrO4. So just by looking at the formula, we can see that each mole of sodium chromate is going to contain 2 moles of sodium. So I'm just going to say 2 sodiums, 1 chromium, and 4 oxygens. And we get that just from the subscripts in its formula. So now let's take those 2 moles of sodium. And if we look up in the periodic table, the atomic mass of sodium, it's about 23 grams per mole. So there are 23 grams of sodium per mole of sodium. So that means that if we have 1 mole of sodium chromate, we're going to have 46 grams of sodium in that mole. Similarly, in that 1 mole of sodium chromate, we have 1 mole of chromium. If we look up chromium in the periodic table, its atomic mass is about 52 grams per mole. So in that 1 mole of sodium chromate, I'm going to have 52 grams of chromium. Finally, 1 mole of sodium chromate is going to have 4 moles of oxygen. And looking up oxygen in the periodic table, its atomic mass is about 16 grams per mole. 4 times 16 is 64, so I have 16 grams of oxygen. So this is the number of grams of each element that makes up the compound. And if I add them all up, I get 162 grams. And 162 grams per mole is the molecular mass of the whole compound, the molecular mass of sodium chromate, Na2CrO4. So now, in order to get the percent composition, I just have to place each of these over the total. Very simple. So I can do that for each of them in turn. So for sodium chromate, the mass percent composition is going to be easy to calculate. The mass percent of sodium is going to be equal to the 46 grams of sodium over the 162 grams of the total. Okay, so this is how much sodium there, the numerator is how much sodium there is in a mole. The denominator is the molecular weight or the molar mass. So this gives me 28% sodium. The percent chromium is going to be equal to the 52 grams of chromium that's in a mole over the total, over the molar mass. 52 divided by 162 is about 32% chromium. Finally, oxygen is going to be 64 grams divided by the total 162 grams, which gives me 40% oxygen. If I add up all these numbers, they add up to 100. So here I have the mass percent composition of sodium chromate. It's 28% sodium, 32% chromium, and 40% oxygen. Let's do another example. Let's calculate the percent of water in copper 2 sulfate pentahydrate. So this is an ionic compound that has water molecules actually as part of the ionic lattice. It's a hydrated salt. So we call this pentahydrate because there are 5 water molecules within the structure of the ionic compound. So in order to do this, first we need to, let's figure out the molecular weight or the molar mass of copper 2 sulfate pentahydrate, the whole thing. So if you calculate that, just looking up the atomic masses in the periodic table, you should find a number of about 249.6 grams per mole. I suggest you pause the video and make sure you can get that molar mass yourself using the periodic table. Now, what is the mass of water? So for water, we have in 1 mole of copper 2 sulfate pentahydrate, we have 5 moles of H2O. Okay, we can see that because we have literally 5 H2Os as part of the molecular structure. Each of them has a molar mass of 18.02 grams per mole. That's just the molar mass of water. So that is going to give me 90.1 grams of water in every mole of copper 2 sulfate pentahydrate. So the mass percent of water in copper 2 sulfate pentahydrate, so in the whole thing, copper 2 sulfate pentahydrate, is going to be equal to that 90.1 grams of water over the mass of the whole compound, the molar mass of the whole compound, 249.6. So that gives me a percentage of about 36.1%. So this salt is going to be just a little bit more than 36% water.